Ever heard of the term dynamic programming and felt like it's some black magic? Don't worry, today we'll make it simple using real life examples and a Java code. By the end of this video, you'll know what DP is and how to use it step by step. Dynamic programming or DP is a way to solve a problem by breaking them down and solving each subproblem once and then saving the result. It's perfect for problems that have overlapping subproblems and optimal substructures. Sounds fancy, but we'll simplify that. So let's take a real life analogy. Imagine you're climbing the stairs. So, first you can take one step at a time or two steps at a time, and then how many ways to reach at the top of a 5 step staircase. Without saving results, you'd repeat the same calculations over and over. So let's solve the staircase problem. So the question is if I can take one step at a time or two steps at a time, and how many ways can I climb n stairs? First, here's the native solution of recursion in Java. This works, but there's a problem. To calculate, say, count weighs 5, it calls count weighs 4 and count weighs 3. But count weighs 4 itself calls count weighs 3's. So the same calculation is done again and again. It's like resolving the problem hundreds of times. That's why recursion here is slower. Now let's improve it using dynamic programming with memorization. That means simply remember what you have solved already. Here, once we calculate count weighs 3, we store the result in DP array. Next time we need count weighs 3, we don't recalculate it, we just look it up. It's like keeping a notebook. Recursion without DP is a forgetful student, redoing the same things over and over again. And DP with memorization is a smart student who writes down the answers so they never solve the same problem twice. That's why dynamic programming is much faster. Real life examples include climbing stairs, calculating the minimum cost path, word brick problem, kick snap problem, and the longest common subsequence. So far, we have seen recursion with memoization. That's called top-down DP because we start with the big problem and then break it down into smaller problems. But DP has another style, that is bottom-up or tabulation. Here, instead of starting at the top and breaking it down, we start with the smallest problem and build our way up. Let's take the staircase example again. Using tabulation, it looks like this. Notice there's no recursion here. We start with the base cases. First one is dp0 equals to 1. That's our first way. So we stay on the ground. Second is dp1 equals to 1. And this is just one step. Then step by step, we calculate dp2 equals to dp1 plus dp0, then dp3 equals to dp2 plus dp1, and so on until we get dpn. So in top down, we asked, how do I climb n steps and broke it down into subproblems. But in bottom up, we say, I already know how to climb the stairs. Let's use that to build up n. Both sides give us same answers. It's like using two different ways of thinking. Use whichever fits the problem best. So here are some personal tips to master dynamic programming. First is start with basic patterns like Fibonacci, climbing stairs, 0 1 kick snap, and long subsequence. Then build a habit. Identify the repeating subproblems, use an array to store the result, and watch for the base case. So, dynamic programming isn't some kind of magic, it's just smart caching and breaking down problems. If this helped you understand DB better, drop a comment, subscribe, and like for more coding videos. Thanks for watching.